November 24, 1942, Velikiye Luki Fortress City, Soviet Union. Captain Dmitri Volkov, 29, from Tula, pressed his face against frozen earth as German 80mm shells turned the street ahead into erupting concrete and flame. His flamethrower tank crew waited in the basement below. Could they survive long enough to reach the German positions? Every minute above ground meant another chance for enemy artillery to find them. What Volkov didn't know, within 48 hours, his improvised tactics would transform Soviet urban warfare doctrine. The cellars of Velikiye Luki would become furnaces that no German engineer had imagined possible. The problem started 3 weeks earlier, when 3rd Shock Army encircled the city. German 83rd Infantry Division had fortified every building. They connected basements with tunnels. Machine gun nests covered every approach. Standard infantry assaults resulted in 200 casualties per city block, with minimal territorial gain. Soviet commanders calculated they would need 4 months to clear the fortress at current rates. Temperature dropped to -22 degrees Celsius. Frozen ground made digging tank ditches impossible. German defenders used basement networks to appear behind Soviet lines, attack supply columns, then vanish underground before artillery could respond. Senior Lieutenant Grigory Kushnir reported losing 47 men in 6 hours trying to capture a single apartment complex. His forces advanced 30 meters. The numbers seemed impossible. 108,000 Soviet attackers, unable to dislodge 7,000 defenders after 3 weeks of combat. But 3rd Shock Army casualty reports confirmed every detail. Volkov watched OT-34 flamethrower tanks approach the German strongpoint at 08:20 hours. Crews had modified standard T-34 chassis by replacing main gun with ATO-41 flame projector. Maximum range, 60 meters. Fuel capacity, 100 liters of thickened petroleum. Problem: German positions were underground where flames couldn't reach. Tank Commander Lieutenant Yakov Markov, 24, from Smolensk, climbed from his vehicle. "We can't burn what we can't see," he told Volkov. "They wait in cellars until we pass, then attack from behind." Volkov studied the apartment building ahead. German troops had reinforced basement ceilings with steel beams taken from destroyed factories. Small ventilation grates provided air circulation. Standard protocol called for engineers to place explosive charges, demolish entire structures, then advance through rubble. Time required per building, 4 to 6 hours. Buildings in Velikiye Luki's center, 340. "What if flames went down instead of forward?" Volkov asked. Markov stared. "Into basements? Through ventilation shafts, or blown-out windows leading to lower floors?" German 83rd Infantry Division commander Colonel Kurt von der Chevalerie documented in his December 2nd report, "Soviet tactics have evolved beyond conventional assault patterns. We cannot predict their next innovation." His staff hadn't yet discovered what Volkov was planning. Engineers from 235th Separate Flame Battalion gathered in the captured brewery basement. Senior Sergeant Pavel Yegorov spread building diagrams across a wooden table. Reconnaissance had mapped underground connections between 14 structures in the northern sector. German troops moved through tunnels, making each building a connected fortress rather than isolated position. "Burn one cellar, they retreat to the next," Yegorov explained. "We need simultaneous strikes." Volkov pointed to ventilation shafts marked on diagrams. "Tank positions here, here, and here. Angle flame projectors down through shaft openings. Seal all exit points with infantry." "Flame descends maybe 10 meters before dissipating," Lieutenant Markov objected. "Cellars are 8 to 12 meters deep. Temperature might not be sufficient." "Not with single burst," Volkov agreed. "Sustained stream. Fill the entire space." What seemed like simple modification would prove catastrophically effective. Nobody had calculated what happened when flamethrower fuel accumulated in enclosed spaces. Testing began December 3rd in abandoned Soviet positions south of the city. Engineers constructed mock cellar matching German specifications, reinforced concrete ceiling, single entrance, 4 ventilation shafts, wooden furniture and debris to simulate occupied space. OT-34 positioned above largest shaft. Markov's gunner released 3-second bursts straight down. Flame disappeared into darkness. Temperature sensors placed in mock cellar registered 340 degrees Celsius. Again, Volkov ordered. Sustained. Second burst lasted 8 seconds. Petroleum fuel poured through shaft opening, coating cellar walls. Ignited droplets fell like burning rain. Temperature reached 580 degrees Celsius. Wooden debris caught fire. Smoke filled the space. Third test used 15-second continuous stream. Results shocked observers. Accumulated fuel created secondary ignition. Temperature spiked to 820 degrees Celsius. Concrete walls cracked from thermal stress. Metal beams sagged. The heat became self-sustaining as furniture and structural materials burned. While Soviet engineers celebrated their breakthrough, German defenders were already experiencing the tactic's early applications. Nobody connected the isolated incidents for 5 more days. Sergeant Hans Weber, 31, from Munich, commanded a machine gun position in Building 47's basement. His squad had held the location for 18 days. Soviet infantry attacks always failed at street level, where interlocking fire dominated every approach. Weber felt secure behind reinforced walls. December 4th, 1430 hours. Unusual engine sounds above. Weber checked periscope. Soviet tank positioning directly over his building. Not advancing, just sitting in place. Strange tactical choice. Probably waiting for infantry support, Weber told his loader. Then flame poured through the ventilation shaft. First burst. Hit the northeast corner. Burning petroleum splattered across ammunition crates. Weber's squad scrambled away from the spreading fire. Smoke filled breathing space. Temperature rose rapidly. "Out!" Weber shouted. "Everyone out!" They rushed toward the tunnel entrance connecting to Building 48. More flame came through western shaft, then southern. The tank above wasn't just attacking, it was methodically filling every opening with fire. Could they reach the tunnel before flames blocked their exit? Weber's decision would be made in seconds. His youngest soldier, Private Josef Schneider, 19, couldn't run fast enough. Smoke inhalation dropped him 4 meters from safety. Weber grabbed the boy's collar, dragged him through doorway as flame washed across ceiling behind them. Heat seared exposed skin. Weber's hands blistered from contact with superheated metal door handle. They emerged in Building 48's cellar. 20 German soldiers already there, evacuated from other positions. Senior Lieutenant Franz Dietrich organized defensive perimeter at tunnel junctions. "How many buildings are they hitting?" Dietrich demanded. "Don't know," Weber gasped. "Maybe all of them." Above ground, 6 OT-34s systematically worked through the northern sector. Volkov directed operations from a captured German half-track. Each tank crew had practiced the technique: position over target building, locate ventilation shafts, deliver sustained flame bursts, move to next structure. Results exceeded projections. Buildings 47, 49, and 52 cleared in 90 minutes. German troops abandoned positions without close combat. Soviet infantry occupied surface levels, while flames continued burning in cellars below. That single tactical innovation multiplied exponentially. Within 6 days, 3rd Shock Army cleared 43 fortified buildings using flamethrower tactics. The entire northern sector's defense network collapsed. But German engineers weren't passive observers. They began modifying defensive positions to counter the threat. Ventilation shafts received steel grating too narrow for flame penetration. Basement entrances got reinforced doors. Some positions had shafts deliberately collapsed and sealed. Volkov anticipated the adaptations. Phase 2 would be more direct. December 9th brought new approach. Instead of attacking through ventilation, engineers blew breaches in basement walls from adjacent buildings. OT-34s positioned in captured cellars fired directly through openings into German-held spaces. No vertical dispersal, pure horizontal flame projection into confined areas. The tactic's brutality shocked even Soviet commanders. Colonel Mikhail Pashkov observed one assault from Building 61. Flamethrower crew pumped sustained stream through blown wall section into German cellar 8 meters away. Defenders had nowhere to retreat. Temperature sensors later retrieved from the position registered peak temperature of 870 degrees Celsius. "Is this necessary?" Pashkov asked Volkov. "Would you prefer losing 200 men per building?" Volkov responded. "Or clearing it with 6 soldiers and 1 tank?" The question had no comfortable answer. Efficiency versus horror. Speed versus humanity. But Soviet casualty rates in the northern sector had dropped by 85% since flamethrower tactics began. German command recognized the crisis. Von der Chevalery's December 12th report to 9th Army headquarters stated, "Conventional defensive positions prove inadequate against Soviet flame warfare. Request immediate tactical guidance or authorization to abandon city center." Authorization never came. Hitler had declared Velikiye Luki a fortress that must hold regardless of cost. German 8th Jager Division attempted relief from the west, but Soviet forces blocked all approach routes. The 83rd Infantry Division was isolated, facing an enemy that had discovered how to turn their strongest defensive positions into death traps. The innovation didn't emerge from high command or specialized warfare schools. Captain Dmitri Volkov had been a metallurgical engineer at Tula Arms Plant before the war. His specialty, industrial furnace design and thermal dynamics. He understood how heat behaved in enclosed spaces, how fuel ratios affected combustion temperatures, how air circulation influenced flame propagation. When 3rd Shock Army mobilized flamethrower battalions in October 1942, Volkov transferred from Rifle Regiment to 235th Separate Flame Battalion. Standard doctrine called for using OT-34 tanks against enemy infantry in open terrain or fortified surface positions. Nobody had seriously considered urban warfare applications where defenders occupied underground spaces. Volkov's insight came from unexpected source. During November 28th assault on Building 34, he watched German soldiers emerge from basement entrance, engage Soviet infantry, then retreat underground before supporting fire could arrive. The pattern repeated 6 times in 40 minutes. "They're using cellars as bunkers," he told Lieutenant Markov, "but bunkers need air circulation. Where there's airflow, flame can follow." What traditional infantry tactics couldn't achieve, physics might accomplish. Could thermal principles from industrial furnaces apply to urban combat? The answer would reshape not just Velikiye Luki's siege, but Soviet urban warfare doctrine for the remaining war years. Volkov's background gave him knowledge other officers lacked. Industrial furnaces reached peak efficiency when fuel was introduced in sustained quantities rather than intermittent bursts. Temperature accumulation required time. Short flame bursts dissipated too quickly. But continuous stream allowed heat to build exponentially as surrounding materials ignited and contributed their own combustion. Standard OT-34 flame projector carried 100 liters of fuel mixture. Petroleum thickened with rubber compounds to improve adhesion. Maximum effective range 60 meters with 3-second burst. Typical engagement 10 to 12 separate bursts per fuel load, each targeting different surface position. Volkov calculated different application. Single sustained stream lasting 25 to 30 seconds. All fuel directed into one confined space. No targeting variety. Total focus on enclosed area where heat couldn't escape. You'll empty entire tank in one attack, Markov objected during December 2nd planning session. One building, Volkov corrected. We'll clear one fortified structure per tank instead of suppressing 10 surface positions that recover after we pass. Engineers ran calculations. Cellar volume, approximately 800 cubic meters for typical Velikiye Luki apartment building basement. Fuel quantity, 100 liters, producing roughly 3.6 million BTUs when fully combusted. Air circulation through ventilation shafts would feed combustion while also serving as delivery route. Temperature projections ranged from 600 to 900 degrees Celsius, depending on cellar contents and ventilation efficiency. At those temperatures, human survival became impossible within 15 to 20 seconds. Defenders would face choice: evacuate immediately or perish. Before innovation, Soviet forces needed 4 to 6 hours per fortified building. Infantry assault, artillery bombardment, explosive demolition, rubble clearing, then cautious advance through destroyed structure. Casualties per building, 30 to 50 soldiers. Building capture rate, 3 to 4 per day across entire division frontage. After innovation, specialized flamethrower teams cleared buildings in 90 minutes. Tank positions above target, sustained flame through ventilation. Infantry secures exits when defenders evacuate. Casualties per building, 0 to 3 soldiers. Capture rate, 8 to 12 buildings per day with single battalion. Senior Lieutenant Anatoly Kuzmin experienced the difference firsthand. His rifle company had spent November 27th assaulting Building 29 using conventional tactics. 3 separate attacks failed. Casualties, 41 killed, 73 wounded. Building remained in German hands. December 5th, Volkov's flame team arrived. Single OT-34 tank, 6-man infantry squad, 1 engineer with building diagrams. Total time from arrival to occupation, 83 minutes. Casualties, 1 wounded when German defender threw grenade during evacuation. I lost 41 men for nothing, Kuzmin said bitterly. Your tank did in 83 minutes what my company couldn't do in a day. Your men weakened their position, Volkov replied diplomatically. We finished what you started. But both knew the truth. Traditional tactics had failed where thermal warfare succeeded. The mechanism itself was straightforward. OT-34 crew maneuvered tank into position directly above target building. Gunner identified ventilation shaft openings, typically 4 to 6 shafts per structure, each 30 centimeters in diameter. Commander selected primary shaft with best angle for flame delivery. Initial burst lasted 3 seconds. Purpose: confirm flame reached cellar level and identify optimal flow angle. Crew adjusted tank position if necessary, sometimes moving 2 to 3 meters to improve shaft alignment. Second burst, 8 to 10 seconds. Fuel began accumulating on cellar floor and coating walls. Temperature rose, but not yet critical levels. Defenders usually didn't evacuate at this stage. They attempted to suppress fire or relocate to protected corner. Third burst, 15 to 20 seconds continuous stream. This was critical phase. Accumulated fuel ignited secondary fires. Wooden furniture, storage materials, structural timber all contributed combustion. Temperature spiked rapidly. Defenders lost remaining oxygen as fire consumed available air. Evacuation became mandatory. Some German positions had multiple exit routes through tunnel networks. Volkov positioned infantry squads at known exit points before beginning flame attack. Defenders emerging from underground faced immediate capture or suppression fire if they resisted. Other positions had single entrance. Defenders trapped inside faced impossible choice: burn or surrender. Most chose surrender once temperature exceeded survivable limits. Advantages extended beyond immediate tactical success. Psychological impact on German morale was severe. Soldiers who experienced flamethrower attacks reported them to commanders as worst aspect of Velikiye Luki combat, worse than artillery, worse than tank fire, worse than close-quarters fighting. Corporal Friedrich Stein, 27, from Dresden, wrote in diary later captured by Soviet forces, "The flame comes from above like judgment from God. You cannot fight it, you cannot hide from it. The heat makes metal too hot to touch. The smoke fills your lungs. Your only choice is run or die. I have never felt such fear." That fear multiplied across German defensive network. Buildings that hadn't yet been attacked saw defenders voluntarily abandon positions when OT-34 tanks approached. The weapon's reputation exceeded its actual deployment. Opposition to Volkov's tactics came from unexpected direction. Soviet military prosecutors investigated whether flamethrower warfare violated established rules of engagement. Major Leonid Vasilyev argued that burning defenders alive constituted unnecessary cruelty when conventional means could achieve similar results. "You're creating conditions where enemy cannot surrender," Vasilyev stated during December 14th inquiry. "Flame fills escape routes. Defenders die before they can exit positions." Volkov presented casualty comparisons. November operations using conventional tactics, 892 Soviet casualties, 41 buildings captured. December operations using flame tactics, 187 casualties, 89 buildings captured. Ratio dramatically favored new approach. "Would you prefer we sacrifice another 700 soldiers to satisfy legal concerns?" Volkov asked. "Our men are dying from German bullets, just as dead as Germans die from our flames." Inquiry concluded with authorization to continue flame operations, but required crews to provide evacuation opportunity before maximum temperature attacks. In practice, this meant initial warning burst, then 30-second pause, then sustained assault if defenders hadn't surrendered. German commanders faced different debate. Some officers advocated abandoning cellar-based defense entirely, moving to surface-level strongpoints where flamethrower effectiveness decreased significantly. Others argued that surrendering underground advantage would make positions even more vulnerable to conventional assault. Captain Wilhelm Becker, 35, from Hamburg, commanded defensive sector in Velikiye Luki's eastern quarter. His analysis dated December 11th recommended hybrid approach, maintain cellar positions but improve ventilation shaft protection, install emergency exits, stockpile water for suppressing fires. Von der Chevalerie approved Becker's modifications. Engineers welded steel grating over ventilation shafts. Crews installed secondary exits, requiring explosive charges to breach but providing emergency escape. Some cellars received water tanks and hand pumps. Adaptations slowed Soviet advance but didn't stop it. Volkov's teams adjusted tactics accordingly. When ventilation shafts proved blocked, engineers used explosives to breach basement walls from adjacent buildings. Flamethrower tanks then fired through holes directly into German-held cellars. No vertical delivery required. December 16th demonstrated adapted technique. Building 73 had all ventilation shafts sealed with steel plates welded to concrete surrounds. Conventional flame tactics wouldn't work. Volkov's engineers spent 3 hours tunneling through Building 72's cellar wall into Building 73's underground level. Breach created opening 80 centimeters wide. OT-34 positioned in Building 72's cellar, flame projector aimed directly through hole. Sustained burst lasted 22 seconds, delivering flame horizontally into target space at point-blank range. German defenders in Building 73 evacuated within seconds. Temperature in their cellar reached 840 degrees Celsius, according to sensors later recovered. Steel support beams had visibly warped from thermal stress. Concrete walls showed heat fractures. One defender who delayed evacuation by 10 seconds suffered severe burns and died from injuries 2 days later. The tactic's flexibility became its greatest strength. Surface ventilation blocked? Attack through walls. Walls too thick? Use explosive charges to create breaches, then deliver flame. Multiple connected cellars? Clear them sequentially with infantry securing each space before advancing. Soviet casualties continued declining as tactics refined. Week of December 7–13. 112 casualties clearing 67 buildings. Week of December 14–20. 89 casualties clearing 81 buildings. German defensive network was collapsing not from overwhelming force, but from thermal precision. Yet, controversy persisted. Frontline soldiers embraced tactics that kept them alive. Staff officers debated whether methods contradicted military ethics. Political officers worried about propaganda implications if Germans publicized Soviet use of flame warfare against fortified positions. General Pavel Kurochkin, 3rd Shock Army commander, resolved debate with pragmatic directive dated December 18th. Flamethrower operations will continue as primary urban assault method. Casualty reduction justifies tactical approach. Crews will document surrender opportunities provided before maximum assault. Political officers will emphasize German defensive brutality rather than Soviet offensive methods in reports. Translation: keep using flames, make it look justified, don't advertise the details. By December 21st, northern and eastern sectors were largely cleared. German 83rd Infantry Division held only Central District and western approaches. What had begun as defensive network of 340 fortified buildings had collapsed to roughly 90 structures still in enemy hands. The siege was entering final phase. First large-scale test came December 7th, targeting Block 14, 6 connected buildings with extensive tunnel network. Soviet intelligence identified approximately 180 German defenders using the complex as battalion headquarters. Conventional assault would require major infantry commitment with predictable casualties. Volkov assembled 4 OT-34 tanks plus 40 infantry for perimeter security. Plan called for simultaneous flame attacks on buildings 56, 58, 60, and 62, forcing defenders toward central structure building 59, where Soviet troops would demand surrender. Execution began 0620 hours. Temperatures stood at -26 degrees Celsius. Crews reported fuel mixture remained viscous despite cold. Thickening agents prevented petroleum from freezing solid. Tank crews positioned within minutes. Lieutenant Markov commanded lead vehicle above Building 56. Projector ready, shaft alignment confirmed, he reported via radio. All units commence attack, Volkov ordered. 4 flame projectors opened simultaneously. Streams of burning petroleum poured through ventilation shafts into 4 separate cellars. The coordinated assault created immediate crisis for German defenders underground. Fire approached from multiple directions. Tunnel connections that had provided tactical flexibility now channeled heat through entire network. German radio intercepts captured frantic communications. Building 56 compromised, retreating to 59. Building 60 untenable, moving to central position. Temperature critical in eastern section. Within 8 minutes, approximately 140 German soldiers crowded into Building 59's cellar. They had evacuated 4 positions simultaneously. Soviet infantry at surface entrances called for surrender. Senior Lieutenant Ernst Vogel, German battalion executive officer, emerged waving, white undershirt tied to rifle barrel. "We surrender. Stop the burning." Total German casualties from flame attack. 3 dead from smoke inhalation who had hesitated during evacuation. Soviet casualties, 0. Time from assault commencement to surrender, 11 minutes. How many more buildings could be cleared before defenders developed effective countermeasures? Results exceeded expectations, but revealed refinement needs. Coordinated multi-building attacks required precise timing. If one tank began early, defenders evacuated toward buildings not yet under attack. Radio communication between crews proved essential, but equipment failures caused coordination problems. Engineers addressed timing issues by assigning each crew visual signaler. Hand signals replaced radio commands for initiating flame bursts. Success rate improved. December 9th operation against Block 9 achieved perfect simultaneity across 5 separate positions. Fuel consumption became critical factor. Original OT-34 design carried 100 liters sufficient for brief engagements. Urban warfare required sustained streams, depleting tanks rapidly. After clearing 2 or 3 buildings, vehicles needed refueling. Senior Sergeant Yegorov proposed solution: mobile fuel trailers positioned in captured areas. Crews could refuel forward without returning to distant supply points. Implementation reduced operational tempo gaps from 90 minutes to 15 minutes between attacks. Tank survivability required attention. OT-34s were vulnerable during positioning phase when stationary above target buildings. German anti-tank teams learned to wait until flamethrower tanks stopped moving, then engage from concealed positions. December 11th, Lieutenant Markov's tank took Panzerfaust rocket hit while preparing to attack Building 87. Warhead penetrated side armor, detonated fuel tank. Resulting explosion killed 3 crew members instantly. Markov survived with severe burns. "They're targeting us specifically now," he reported from Field Hospital. "They know if they destroy flame tanks, conventional defenses work again." Tactical adjustment implemented December 13th. Infantry scouts cleared surrounding positions before OT-34s approached target buildings. Suppressive fire from supporting weapons discouraged German anti-tank teams from exposing themselves. Flamethrower tank losses dropped from 3 vehicles per day to 1 vehicle per week. Crew training evolved rapidly. Initial flame operators came from conventional tank backgrounds with limited specialized instruction. Urban warfare demanded different skills: understanding building layouts, identifying optimal shaft positions, calculating fuel requirements for varying cellar volumes. Lieutenant Pyotr Sokolov, 26, from Kiev, developed training program using captured German buildings in southern sector. New crews practiced on abandoned structures before deploying against active targets. Training reduced fuel waste by 40% as crews learned efficient delivery techniques. "You can't just point and shoot," Sokolov explained to replacement operators. "Angle affects how fuel disperses. Too steep, it pools without spreading. Too shallow, it dissipates before reaching cellar floor. Optimal angle: 35 to 40 degrees from horizontal." Such technical precision transformed flamethrower warfare from desperate improvisation to refined doctrine. German countermeasures continued evolving. Some positions installed water systems capable of flooding cellars rapidly when flame attack began. Theory: rising water would extinguish fires and reduce temperature. December 15th. Test of this defense occurred at Building 104. German engineers had connected building to damaged water main, rigged manual valve in cellar. When OT-34 began flame attack, defenders opened valve flooding basement with 2,000 liters per minute. Initial results looked promising. Temperature rose only to 420 degrees Celsius, survivable for short duration. Flames couldn't maintain combustion with water accumulating on floor. But physics defeated the countermeasure. Burning petroleum floated on water surface. As water level rose, flame layer rose with it. Defenders found themselves trapped between rising water and descending fire. They evacuated within 3 minutes. "Water made it worse," Corporal Hans Weber reported after capture. At least with fire alone, we knew where the danger was. With water rising and flames floating, we had nowhere safe. Could any defensive modification stop the flame attacks? German engineers tried multiple approaches over following weeks, but none proved effective. Some cellars received concrete baffles blocking line of sight from ventilation shafts to main occupancy areas. Theory: flame would hit baffle and disperse without penetrating deeper into cellar. Testing proved otherwise. Flames followed air currents around obstacles. Heat accumulated regardless of baffle placement. Temperature sensors showed only 80-degree reduction, insufficient to prevent evacuation. Other positions tried sealing themselves completely, eliminating all ventilation. Defenders would rely on limited air supply, gambling that Soviet attacks would be brief. This approach failed catastrophically at Building 119 on December 18th. German troops sealed all ventilation shafts with concrete, believing they could outlast flame attacks. Volkov's team responded by delivering sustained 35-second burst through partially blocked shaft. Even with restricted airflow, temperature inside reached 670 degrees Celsius. Sealed environment prevented heat from escaping. When defenders finally broke through emergency exit trying to evacuate, superheated air rushed out with explosive force. 4 soldiers suffered critical burns from the thermal blast. The sealed cellar approach was abandoned immediately afterward. Soviet refinements continued. Engineers developed shaped charges specifically for creating flame delivery holes in basement walls. Standard explosives often made irregular breaches difficult for precise flame projection. New charges created clean circular openings 60 centimeters in diameter, perfect size for OT-34 projector nozzle. December 20th, demonstrations showed effectiveness. Engineers breached Building 127's cellar wall in 12 minutes using shaped charges. Flamethrower tank positioned directly against opening delivered flame at point-blank range. German defenders surrendered after 6-second burst. They recognized futility before maximum temperature was reached. Psychological aspects became more pronounced as tactics matured. German soldiers who had experienced flame attacks exhibited severe stress symptoms. Medical officers reported increased cases of what they termed cellar panic, acute anxiety, when assigned underground defensive positions. "My men refused to enter basements," Captain Wilhelm Becker reported December 22nd. "They would rather defend surface positions where they can see the enemy and have space to maneuver." Von der Chevalerie faced impossible situation. Surface positions offered no protection from Soviet artillery. Underground positions triggered psychological collapse from flame attack fears. No defensive option provided both physical safety and mental stability. Soviet intelligence intercepted German radio message December 23rd. Morale critical. Troops believe flame death inevitable. Request authorization for tactical withdrawal. 9th Army Headquarters response. Withdrawal prohibited. Hold all positions per Führer directive. The fortress would not be abandoned voluntarily. It would burn until nothing remained. Cold weather created unexpected challenges for Soviet crews. Fuel viscosity increased as temperatures dropped below -30 degrees Celsius. Even with thickening agents, mixture flowed poorly through projector mechanisms. Range decreased, combustion efficiency dropped. Engineers added heating elements to fuel tanks, using engine coolant circulation to maintain petroleum temperature above -10 degrees. Modification restored performance, but required 20 minutes warm-up time before operations. December 25th brought severe cold snap, -38 degrees Celsius. Several OT-34s experienced fuel line freezing despite heating systems. Operations suspended for 6 hours, while crews thawed equipment and improved insulation. "We're fighting Germans and physics simultaneously," Yegorov observed. "At least physics follows predictable rules." By month's end, flamethrower tactics had achieved remarkable success. Soviet forces controlled 80% of Velikiye Luki's urban area. German 83rd Infantry Division held only Central District, approximately 60 buildings. Defenders numbered fewer than 2,000 combat-effective soldiers. But those remaining defenders occupied strongest positions. Buildings around German command post had reinforced construction, multiple escape routes, improved fire suppression systems. Final phase would test whether flame warfare could overcome prepared defenses or if conventional assault would be necessary. Volkov studied maps of remaining German territory. Every building was documented, every ventilation shaft marked, every tunnel connection identified. Soviet intelligence had acquired comprehensive understanding of enemy defensive network. "We've learned everything possible from experimentation," he told assembled officers December 31st. "Now we apply that knowledge to finish the siege." Final assault would commence within 48 hours. The coldest, most fortified section remained. Would tactics that had worked against isolated buildings succeed against concentrated, prepared defense? Captain Volkov detected movement in Building 142's upper windows at first light January 2, 1943. German observers tracked Soviet positions from fourth-floor vantage point. The building anchored northwest corner of remaining defensive zone. Taking it would expose enemy flanks to direct fire. His assault team assembled in captured Building 139, separated from target by 35 meters of rubble-filled street. 3 OT-34 tanks waited in basement level. Infantry squad had secured adjacent positions overnight. Attack would begin at 0730 hours. Temperature stood at -31 degrees Celsius. Fuel heating systems had been running for 40 minutes to ensure proper viscosity. Lieutenant Sokolov commanded lead tank, his crew veteran of 23 successful building clearances. "Building 142 has reinforced construction," Volkov briefed. "Intelligence indicates double-thick basement ceiling. May require extended burn duration." Could standard tactics overcome enhanced defenses? The answer would determine approach for remaining strong points. Sokolov's tank advanced first, treads grinding across frozen debris. German machine gun opened fire from second floor. Bullets sparked off frontal armor without penetrating. Tank reached Building 142's foundation, positioned above largest ventilation shaft. "Shaft located. Angle optimal," Sokolov reported. "Commence attack," Volkov ordered. Initial 3-second burst confirmed flame reached cellar level. Observers saw orange glow through basement windows facing courtyard. 8-second follow-up poured burning petroleum into underground space. Nothing happened. No evacuation. No surrender calls. German defenders remained in position. "Extended burn authorized," Volkov transmitted. Sokolov's gunner opened continuous stream. 5 seconds. 10 seconds. 15 seconds. Fuel gauge dropped toward empty. Temperature sensors suggested heat was building, but slowly. Reinforced ceiling absorbed thermal energy before it could accumulate in occupied areas below. 20 seconds. 25. Tank fuel exhausted. "No effect," Sokolov reported. "Defenders still active." German soldiers emerged from ground floor entrance, attacked Soviet infantry, positions with grenades and submachine gun fire. Brief firefight resulted in 4 Soviet casualties before defenders withdrew inside. The flame attack had failed. Volkov reassessed. Standard tactics proved insufficient against enhanced construction. Thicker ceilings dissipated heat. Greater thermal mass required more energy input to reach critical temperature. "Bring forward second tank," he ordered. "Sequential burns. Accumulate heat faster than structure can absorb it." Second OT-34 advanced, positioned over different ventilation shaft. This crew delivered entire fuel load in one sustained 28-second burst. Combining both attacks, Soviet forces had pumped 200 liters of burning petroleum into Building 142's cellar within 5 minutes. Temperature finally reached critical levels. German defenders evacuated through ground floor exits into Soviet fire positions. 17 surrendered. 8 were killed attempting to fight through encirclement. Buildings secured by 0812 hours. Lesson learned. Reinforced positions required multiple tank attacks or much larger single fuel load. Engineers began developing 200-liter fuel trailer that could connect directly to OT-34 projector system, enabling sustained burns up to 60 seconds duration. Dawn on January 4th revealed German defensive preparations. Overnight, defenders had erected barricades around remaining strongpoints. Steel beams, concrete rubble, and salvaged equipment created obstacles preventing direct tank approaches to buildings. Building 156 presented typical challenge. Barricade extended 8 meters from foundation, positioned to block vehicle access to ventilation shaft locations. Infantry could approach on foot, but without armor support, casualties would be severe from defensive fire. Sergeant Yegorov proposed indirect solution. We don't need to be directly above shafts. Angle flame trajectory. Engineers calculated projector could maintain effective range up to 15 meters if elevated properly. Tank positioned behind barricade on rubble pile could fire over obstacle into shafts beyond. Testing proved concept viable, but accuracy suffered. Only 60% of fuel reached target areas. Remainder splashed against barricades or missed shafts entirely. Wasteful but workable when alternative was frontal assault. Building 156 attack commenced 1140 hours. OT-34 positioned on demolished wall section providing elevation. Gunner aimed carefully, released sustained burst. Flaming petroleum arced over barricade, much of it splashing into ventilation shafts as intended. Results were mixed. Temperature rose sufficiently in eastern cellar section to force partial evacuation. But western section remained tenable. Defenders shifted positions underground, maintaining defensive capability. Second burn required, Volkov acknowledged. Elevated angle reduces precision too much for single attempt success. 3 additional tanks attacked Building 156 from different positions. Over next 2 hours. Cumulative fuel delivery finally overwhelmed defensive position. German troops evacuated completely by 14-20 hours. Buildings secured. But tactical efficiency had declined sharply. 4 tanks clearing 1 building versus original doctrine of 1 tank per building represented significant capability reduction. Under intense pressure, at 0920 hours January 6th, German counterattack hit Soviet positions around Building 163. 24 enemy soldiers emerged from previously undetected tunnel, struck from behind Soviet lines. Brief but intense combat killed 6 Soviet troops before defenders withdrew underground. Lieutenant Markov, returned from hospital despite incomplete recovery from earlier burns, led response. His tank couldn't approach Building 163 from surface. German anti-tank teams controlled all approaches, but captured tunnel network offered alternative. We go underground, Markov announced. Attack through their own tunnels. Crew maneuvered OT-34 into Building 161's cellar via demolished floor opening. Tank barely fit through. Clearance was 15 centimeters on each side. Careful driving advanced vehicle through basement toward tunnel entrance, connecting to Building 163. This is insane, Gunner Corporal Alexei Volkov muttered. Not related to Captain Volkov, but shared concern for enclosed space combat. Tank reached tunnel junction. Opening was too narrow for vehicle passage, but projector nozzle extended through with room to spare. Range to enemy position, Markov asked. 12 meters through tunnel, infantry scout reported. Fire when ready. Flame-filled underground passage. Unlike surface attacks where heat could dissipate upward, tunnel concentrated thermal energy. Temperature spiked instantly. Pressure wave from combustion blew back through Soviet positions. Markov's crew felt heat even inside armored vehicle. German defenders in Building 163 had no warning. Flame came through tunnel entrance traveling at walking speed, filling cellar in seconds. Every occupant was forced to evacuate immediately. 19 surrendered. 4 died from burns or smoke inhalation before reaching exits. The underground attack technique proved effective, but extremely dangerous. Tank crews faced risk of fuel explosion in confined spaces. Infantry supporting operations breathed superheated air that caused respiratory damage. 3 Soviet soldiers required medical treatment for heat injuries, despite never entering flaming areas. Use tunnel attacks only as last resort, Volkov ordered January 7th. Surface operations remain primary doctrine. Yet tunnel tactics provided solution for seemingly impregnable positions when conventional approaches failed. At 15:20 hours January 9th, massive explosion rocked Building 178. German engineers had rigged defensive position with captured Soviet ammunition, creating improvised mine that detonated when OT-34 positioned above. Tank destroyed. Crew killed. Instantly. Shrapnel wounded 4 nearby infantry. German defenders recognized pattern. Soviet flamethrower tactics were predictable. Tank approaches building, positions above shafts, delivers flame. Defense. Mine the expected positioning points. Intelligence reports confirmed Germans were booby-trapping ventilation shaft areas in multiple remaining strongpoints. Simple approach tactics would result in unacceptable tank losses. Soviet engineers developed countermeasure, remote flame delivery. Extended fuel hoses allowed projector nozzle to separate from tank by up to 20 meters. Crew positioned vehicle in protected location. Infantry advanced hose to shaft openings. Attack commenced with tank out of blast radius. First test came January 11th at Building 184. Engineers had detected probable mines around all ventilation shafts. Infantry squad crawled forward under covering fire, dragged 18-meter fuel hose to largest shaft. Tank remained behind protective wall. Projector ready, gunner reported via field telephone line running parallel to fuel hose. Fire, Volkov ordered. System worked imperfectly. Hose kinked under pressure, reducing flow rate. Range decreased to 40 meters maximum, but no tank losses occurred. Building 184 cleared without armor casualties. Remote delivery became standard for suspected mined positions. Slower, more complex, but substantially safer. Adaptation maintained operational capability despite German countermeasures. Weather turned brutal January 13th. Blizzard conditions reduced visibility to 10 meters. Temperature dropped to -41 degrees Celsius. Fuel heating systems struggled to maintain operational temperature. Several OT-34s experienced mechanical failures. Operations suspended for 36 hours. Soviet troops used weather cover to reposition forces, consolidate captured territory, repair equipment. German defenders gained brief respite, but no strategic advantage. They were still encircled, still facing inevitable defeat. Blizzard cleared January 15th. Soviet assault resumed against remaining 22 German-held buildings clustered around command post in city center. These represented strongest fortifications with most determined defenders. Von der Chevalery's headquarters occupied Building 201, heavily reinforced pre-war structure with deep basement and extensive tunnel connections. Final phase would test whether flame warfare alone could reduce the strong point or if conventional assault remained necessary. Volkov coordinated largest single operation since siege began. 8 OT-34 tanks, 12 infantry squads, engineering support with explosives and extended fuel systems, artillery battalion providing suppression fire. "We hit them everywhere simultaneously," Volkov briefed assembled commanders. "Overwhelming thermal assault. No time to adapt or respond." Attack commenced 0645 hours January 16th. 8 separate buildings under flame attack within 90-second span. German defenders faced impossible situation. Evacuating from multiple positions simultaneously overwhelmed their tunnel network capacity. Soldiers fleeing Building 197 collided with troops evacuating Building 199 in underground passage. Panic spread. Some defenders surrendered immediately. Others fought their way towards surface exits where Soviet infantry waited. Building 201, German command post, received special attention. 3 tanks positioned at different shafts delivered coordinated burns. Von der Chevalerie radioed 9th Army headquarters at 0720 hours. Position untenable, requesting authorization for final breakout attempt. Response came 15 minutes later. Authorization granted. Destroy all equipment and documents. Break through to German lines if possible. Von der Chevalerie assembled remaining 340 combat-effective soldiers for desperate assault. Plan called for concentrated attack through Soviet positions in southwest sector, where defenses appeared weakest. Speed and surprise would substitute for lacking combat power. German breakout began 08:15 hours. Defenders emerged from multiple buildings simultaneously, assaulted Soviet lines with remaining ammunition and grenades. Initial shock disrupted Soviet forward positions. Several squads fell back under intense pressure, but Soviet reserves responded within minutes. Machine gun positions established crossfire. Artillery delivered pre-planned bombardment on German assault routes. The breakout stalled after advancing only 200 meters. Von der Chevalerie was wounded by shrapnel. His executive officer, Major Karl Brenner, assumed command. Surviving Germans retreated to Building 201, now burning from sustained flame attacks. They had no choice but surrender. White flag appeared from command post at 0847 hours. Soviet forces accepted capitulation. Velikiye Luki was secured after 54 days of siege. Final German casualties in last 48 hours, 89 killed, 251 captured. Soviet casualties same period, 34 killed, 78 wounded. The numbers told story. Flame warfare had achieved what conventional assault couldn't. Urban fortress reduced without massive Soviet casualties that usually accompanied such operations. During 67 days of siege operations, Soviet flamethrower units cleared 247 fortified buildings using thermal warfare tactics. This represented 73% of total German defensive positions in Velikiye Luki. Average building clearance time, 87 minutes. Soviet casualties per building cleared, 2.3 soldiers. Comparable conventional assault casualties, 38.6 soldiers per building, based on November operations data. The numbers demonstrated revolutionary improvement in urban warfare efficiency. Traditional infantry tactics at Velikiye Luki produced casualty rate of 1,600 per 100 buildings captured. Flame tactics reduced that to 230 per 100 buildings, 86% casualty reduction while dramatically increasing capture rate. Total German losses at Velikiye Luki, 6,014 killed, 1,976 captured. Soviet losses, 31,774 casualties, including 10,004 killed. Exchange ratio heavily favored defenders in conventional warfare terms. But 72% of Soviet casualties occurred during November operations before flame tactics were fully implemented. December-January operations produced only 8,700 casualties while clearing 80% of fortress, demonstrating tactical evolution's impact. What seemed like tactical innovation at city-level siege would reshape Soviet urban warfare doctrine across entire Eastern Front and influence post-war military thinking globally. Immediate strategic impact extended beyond Velikiye Luki itself. German 83rd Infantry Division's destruction removed veteran formation from 9th Army order of battle. Relief attempts by 8th Jaeger Division had failed, costing additional 2,400 German casualties without achieving objective. Soviet victory secured important railway junction and road network, improving logistics for future operations toward Smolensk. But tactical implications proved more significant than strategic gains. Success at Velikiye Luki demonstrated that prepared urban defenses, previously considered nearly impregnable without massive casualties, could be overcome through specialized warfare methods. Doctrine evolved rapidly across Soviet fronts. Stavka distributed Velikiye Luki tactical reports to all army groups by February 1943. Flamethrower battalions received priority equipment allocation. Training programs incorporated lessons from Volkov's innovations. Urban battles at Stalingrad had demonstrated horrific cost of building-by-building combat. Soviet casualties exceeded 400,000. Velikiye Luki offered alternative approach. When Red Army reached cities like Vitebsk, Minsk, and Königsberg in subsequent campaigns, flamethrower tactics became standard preliminary assault method. Post-war analysis by U.S. Army ground forces documented Soviet flame warfare evolution. Report dated November 1945 stated, Soviet employment of flamethrower tanks in urban terrain represents significant tactical innovation. Casualty reduction documented at Velikiye Luki influenced Red Army doctrine throughout 1943 to 1945 operations. Western forces should consider similar capabilities for future urban warfare scenarios. Cold War military thinking incorporated these lessons. American M67 flamethrower tank development drew directly from Soviet OT-34 combat experience. British Crocodile flamethrower modifications reflected understanding that urban warfare required specialized thermal assault capability. Modern military forces abandoned flamethrower weapons by 1970s due to international conventions and ethical concerns. But principle remained. Urban fortifications require unconventional solutions when conventional tactics produce unacceptable casualties. Thermobaric weapons, bunker-busting munitions, and precision-guided explosives serve similar doctrinal role today. Captain Dmitri Volkov received Hero of Soviet Union decoration March 1943 for developing flame warfare tactics. He survived the war, returned to Tula Arms Plant, continued metallurgical engineering work until retirement in 1968. Volkov rarely discussed Velikiye Luki combat, reportedly uncomfortable with fame derived from thermal warfare's brutal effectiveness. He died 1979, age 66. Lieutenant Pyotr Sokolov commanded flamethrower battalion through remainder of war. His unit participated in urban battles at Vitebsk, Minsk, and Berlin. Wounded 4 times, but survived. Post-war career included training command and tactical doctrine development. Published memoir 1962 titled Fire and Steel, documenting urban warfare evolution. Died 1987. Could anyone have predicted that industrial furnace principles would revolutionize urban combat? Senior Sergeant Pavel Yegorov remained with 235th Separate Flame Battalion until unit disbanded 1944. Transferred to conventional tank forces, participated in Vistula-Oder offensive. Killed January 1945 during fighting near Warsaw. His tank struck mine. Posthumously promoted to lieutenant. Lieutenant Yakov Markov recovered from burns sustained at Velikiye Luki, but never returned to combat duty. Medical discharge, March 1943. Worked as machinist in Smolensk until 1978. Interviewed multiple times by military historians researching flame warfare tactics. Died 1981, age 63. Colonel Kurt von der Chevalerie survived captivity, repatriated to Germany 1948. Never faced war crimes charges despite combat at Velikiye Luki. Published defensive analysis, 1952, arguing that adequate air support and reinforcement could have prevented fortress loss. Disputed Soviet casualty claims, suggesting Red Army losses exceeded 50,000. Post-war Soviet records confirmed actual figure near 31,174. Von Chevalerie never accepted the numbers. Died 1954. November 24, 1942, Captain Volkov had pressed his face against frozen earth while German shells erupted around him. He'd wondered if his crew would survive long enough to test impossible idea about flame and physics. The answer transformed urban warfare forever.